All right, we have two right triangles here. We know they're right triangles in this scenario because I'm going to tell you they are by putting the right angle symbol in each one. In example number one, we're going to give the lengths of the legs measurements. So I'm going to assume in problem number one that the length of this leg right here is 5, and the length of this leg right here is 12, and I want you to find the length of the hypotenuse. So if we're trying to find the length of the hypotenuse, as far as the Pythagorean theorem goes anyway, we are trying to find the value of c, because remember, the Pythagorean theorem is a squared plus b squared equals c squared. So by putting the numbers that I get for the sides, the legs, in for a and b, I should be able to solve for c. So putting the numbers in, I'm going to get 5 squared plus 12 squared equals c squared. Now, anytime you're going to do this for me, I would expect to see the Pythagorean theorem set up. So when I ask you a question on a test or even in class, I'm going to ask you, tell me how you set up the Pythagorean theorem, and it needs to look like that. 5 squared, 25. 12 squared, 144, equaling c squared. 25 plus 144 is 169, and that's equal to c squared. That's not the final answer, because we don't want to know what c squared is. We need to know what c is. So to undo squaring, you square root. The square root of c squared is c, and the square root of 169 happens to be 13. So the length of the hypotenuse in problem number 1 is 13. Example number 2 looks similar to example number 1. In other words, it's a right triangle. You've got two sides, and you're trying to find the third. But the difference between this and example number 1 is I'm not looking for the hypotenuse now, so I'm not looking for c. I'm looking for one of the legs. So the number we're looking for is either a or b, depending on which number you want it to be. I'm going to call the missing leg a, and you'll see me do that most of the time because it just makes it a little easier when we solve it. So again, setting up the Pythagorean theorem, I'll have a squared, because that's that side, plus 9 squared, which I'm going to make that my b, equaling c squared, which is 41 squared. So a squared plus 81 equals 41 squared, which, help there, 41 squared, is it 1681? I think it is. Yep. Subtracting 81 from both sides, a squared is equal to 1600, and taking the square root of 1600 to find a comes out to be 40. That means my other leg is 40. We don't have to go through and recheck every number, but what we should look at is, does it make sense that this answer needs to be smaller than the hypotenuse? And the answer is yes, it does, because the two legs cannot be greater than the hypotenuse. They must both be smaller. Where's the pause button? Where's the pause button? I lost it. This is all being recorded, by the way. Does anybody see it? Oh, I probably have to hit the recorder. Where'd it go? Is it hidden? Where?